Good morning, Year 8. So today we're going to look a bit further at quadrilaterals. We're looking at the properties of quadrilaterals. So that's all the different things that happen with each of the quadrilaterals that we've done. So we've been looking at 6 different kinds of quadrilaterals. So for each one you need to be familiar with all the different things that can happen for each quadrilateral. So the first thing you're going to do is to copy the table on pages 135 and 136 in your textbook. It starts at the bottom of page 135. I'll just show you. Okay, so you're going to start your table down here. So you've already got your heading down, properties of quadrilaterals. So this line down here is the first line of your table. Then if you turn the page, you will see the rest of the table. Okay, so up here, you can see this is the rest of the table that you're doing. All right, so here we've got 1, 2, 3, 4, 5 different shapes, but we had one on the other page. So there's 6 shapes you need to do. So you probably need one whole page in your X workbook. So if you've already divided it into columns, it's probably fine. So on the left-hand column, for one whole page, you can do the 6 different shapes. And then on the right-hand column, you've just got to leave enough room to do each of the properties for each shape and then rule off after you've done each of them. Okay, so I'll give you time to do that. Obviously, I'm just going to keep talking in a minute, but you just need to pause the video in a minute while you write all of that down. But before you go, there are some blank spaces. So leave those bits blank and I'm going to tell you what those answers are in a minute. So just pause the video now and I'll be back in a minute to tell you what should be in those blank spaces. Okay, I hope you've paused the video. So now we're just going to come back and have a look. So in this first row of your table that you should have done, you have the trapezium and it says, one pair of opposite sides are. You should have the word parallel there. So one pair of opposite sides are parallel. That's all that happens with a trapezium. It doesn't have too many properties. That's it. Okay, so the next one, if you turn the page or have a look in your table, the second shape was the kite. So there were 3 different dot points for the kite. So the first one said 2 pairs of adjacent sides are. Okay, if you look at that kite, 2 pairs of adjacent sides. So if we look at the sides next to each other, the adjacent ones next to each other, they're equal. So it should be 2 pairs of adjacent sides are equal. The second dot point said 1 pair of opposite something are equal. So 1 pair of opposite something are equal. If you look at the kite, you have an angle here on the left and another angle over here on the right that they've marked. Those 2 angles look equal. That's because they are. So it has 1 pair of opposite angles equal. So make sure you write the word angles in the second dot point. In the third dot point it says diagonals intersect at. So the diagonals go from one corner to the opposite corner. That's one diagonal, and one corner to the opposite corner. The diagonals intersect at right angles. You can actually see the little right angle in there that they've marked. Okay, so they cross at right angles. Intersect or cross at right angles. Okay, the next shape is the parallelogram. There are 4 dot points for the parallelogram. The first one says something sides are equal. So if you look at your parallelogram, it's the opposite sides that are equal. Okay, so make sure you write the word opposite in there. The second dot point says opposite something are parallel. Well, you can't have angles that are parallel, so it's opposite sides are parallel. The third dot point says opposite angles are. All right, now with this one, some of you might not quite understand it. So in the parallelogram, we're looking at opposite angles. So if you look at this whole angle here, and this whole angle opposite it, way over here, they are actually equal to each other. So that whole angle in the top right corner equals the whole angle in the bottom left corner. They both look like they're they both look like acute angles, and they look equal. So we're going to write opposite angles are equal. The fourth dot point says diagonals something each other. Well, here are the diagonals, the two lines that go from one corner to the opposite corner, or one vertex to the opposite vertex. So what do the diagonals do to each other? They actually cross each other, but we're not going to use the word cross because that's not very mathematical. They cut each other. We're not going to use the word cut because that's not very mathematical. They actually cut each other in half. So this diagonal here cuts the other one into two equal pieces. The word we use there is bisect. So make sure on the fourth dot point you have diagonals bisect each other in the parallelogram. Okay, we're up to the rhombus. The rhombus has 5 dot points. It's getting a very special shape. It's got a lot happening. Okay, the first one says all something are equal. Well, you should know the definition of a rhombus is that all the sides are equal. So all sides are equal should be there. The second dot point says something sides are something. And then the next one says something angles are something. Well, with the sides, we can say opposite sides are equal. We could also say opposite sides are parallel. So it's a bit hard to know what they want there. You could say opposite sides are equal and parallel. In the third dot point, you can say opposite angles are equal. Angles can't be parallel. Okay, the fourth dot point for the rhombus, diagonals bisect each other at something angles. Well, from the last one, that might have given you a little clue. Diagonals bisect each other at right angles. So if you look at the rhombus, here's the diagonals of the rhombus. They are bisecting each other, which means cut into two equal parts. And they've shown you that with the two equal markings there. And this one here, the two equal markings here. But there's also a little right angle in there. Okay, so that means the diagonals bisect each other, but also they do it at right angles. The last dot point for the rhombus, diagonals something the angles of the rhombus. Okay, this one's very misinterpreted. Okay, the angles of the rhombus means the 4 angles in the corners of the rhombus. Okay, so what's the diagonal doing to the angle in the top right-hand corner and the bottom left-hand corner? Well, that diagonal is actually splitting that angle in the top right-hand corner into 2 equal parts. And when you cut into 2 equal parts, we use the word bisect. Bi means 2 and sect means cut. So on the last one for rhombus, diagonals bisect the angles of the rhombus. Okay, in E, the rectangle, we have 5 dot points. The first one, opposite sides are equal. In the second one, opposite sides are also parallel. If you want to reverse those, you can. Equal and parallel are the first two. The third dot point, all angles are, well, you could say equal here, but you could be more specific and say right angles. So all angles are right angles. The fourth dot point, diagonals are, well, if you look at a rectangle, the 2 diagonals are equal. They're equal in length, okay? And if you ever look at something where you're trying to get something straight, so you might be making a gate for the side of between the side of your house and the fence. You want a side gate. You will often see that when they make a gate, they sometimes put a brace on it that goes on a diagonal, okay? If they want to check that those 2 sides are vertical the way they're supposed to be for a gate, they might check that those two diagonals on the gate are the same length. If they're the same length, we know this whole thing is going to be rectangular the way it should be. Okay, so the diagonals in a rectangle are equal. That's the fourth dot point. The last dot point for the rectangle, diagonals something each other. Well, again, we've seen this before. Here's your two diagonals. What are they doing to each other? That diagonal is cutting the other diagonal into two equal parts. So we're going to use the word bisect. And the same thing, this diagonal is cutting this diagonal into two equal parts. So diagonals bisect each other. You'll notice that in the rectangle they don't say the diagonals bisect each other at right angles because there are not right angles in between the diagonals of a rectangle. You'll notice they look a little bit like this. Okay? So there's no right angle between my two hands here. You can't see a right angle there. Okay? So sometimes it might look like that, or it might look like this. It doesn't have a right angle there. For there to be a right angle there, it would have to be a square. So let's look at the next one. We are doing the square. So we have 5 dot points. A lot happens with the square. So all sides are equal. We should know that one. All angles are equal, and they're also right angles. So let's say all angles are right angles. The third dot point, opposite something are parallel. You can't have parallel angles, so it must be opposite sides are parallel. The fourth dot point, diagonals are, those two diagonals on the square are equal in length. So diagonals are equal. And the last dot point, diagonals bisect each other at. So look at the diagonals on the square. So when you look at the diagonals on the square, here's your two diagonals. They've already told you that they're bisecting each other. So this diagonal is cutting this other diagonal into two equal bits. And this diagonal is cutting this one into two equal bits. But it happens at right angles. So this one does have right angles here. The rectangle did not. They don't look like right angles in there. But this one does. So the last dot point, diagonals bisect each other at right angles. Okay, we're going to do a few questions just on understanding that table. So once you've got that table completed, you're going to write down this heading examples and this question. So we're going to look through the shapes in your table as we try and answer these questions. Okay, so it says which quadrilaterals have each property? So we're looking at this one first. Opposite angles are equal. So we're going to look through all the shapes in your table one by one. So we want to see which shapes have opposite angles equal. Well, the trapezium definitely doesn't. There's not much happening with the trapezium. So if you look at your trapezium, the opposite angles in that shape do not look equal to each other. Let's have a look at the kite. There is one pair of opposite angles equal in the kite, but not the other pair. So if you have a look at the kite, that top angle and the one down the bottom are opposite angles and they're not equal to each other. This one at the bottom looks a lot smaller, that angle, a lot sharper than the one at the top. So we can't say it's happening with a kite, even if it's happening with one pair of opposite angles. It's not happening in general. Okay, the parallelogram. If you look at your parallelogram, the opposite angles are equal in the parallelogram. The parallelogram looks like that, if I just draw it very quickly. This angle and this one are equal. They look equal. And this one is equal to this one. They look equal. So they probably are. All right, the next shape that we're looking at is a rhombus. Well, it's going to happen with a rhombus because if it's happening with a parallelogram, a rhombus is just a special kind of parallelogram. Happens to just have all its sides equal. Okay, so if it's happening with that, it's definitely going to happen with the rhombus as well. Okay, the next shape is the rectangle. A rectangle, the opposite angles are equal. So if you think of a rectangle, it looks like that. I could draw the right angles here. Well, let's do it. There's the opposite angles, they're equal. And here's some opposite angles, they're equal. So it is happening with the rectangle. And of course, if it's happening with a rectangle, it's going to happen with the square, because the square is just a special kind of rectangle that happens to have all its sides equal as well. So there's all the ones where it applies. Let's look at the next one. So we have diagonals bisecting each other. So the first shape in your table is a trapezium. Not much happens with the trapezium. Those diagonals do not bisect each other into trapezium. Let's look at the next kite. The kite, with the kite, you have this diagonal that goes from top to bottom does split the other diagonal into 2 equal bits, so it does bisect it. However, this short diagonal does not split the long diagonal into 2 equal bits. So just because it's happening with one diagonal doing it to the other, it doesn't happen the other way around, so we can't say it happens with the kite. Okay, the parallelogram. Does the diagonals bisect each other in the parallelogram? If you have a look at the way we fill the table in, or look at the parallelogram yourself, it does. Okay, here's your parallelogram. Here's your diagonals. Do they bisect each other? They do, because that will equal that, and that will equal that. Okay, the next one that we're looking at is the rhombus. If it happens with the parallelogram, it will happen with the rhombus. Rectangle. It does happen with the rectangle. Let's have a look at it. Okay, there's your 2 diagonals. That equals that. So this diagonal has cut this into 2 equal bits. And these are actually the same length. All 4 of these pieces are the same length. So it's also happening on the other one. And again, if it happens with a rectangle, it will have to happen with the square, because that's just a special kind of rectangle. Okay, the next one we're looking at in C. Adjacent. Remember, adjacent means next to. Next to each other. So we want the sides that are next to each other to be of different lengths. Okay, so if we have a look at the trapezium, that definitely happens there. The sides next to each other are different lengths. These 2 next to each other are different lengths. These 2 next to each other are different lengths. So this does actually happen with the trapezium. Okay, so the next one, we're looking at the kite. The kite, it doesn't happen, because that's one of the features of a kite, is that the adjacent sides are equal to each other. So they're not going to be different lengths, so we can't say it for a kite. All right, the parallelogram. Yes, it does happen with the parallelogram. Let's have a look at it. There's your parallelogram. There's 2 sides next to each other. They are different lengths. Then if we look at this one and this one, they are different lengths. Look at this one and this one, they are different lengths. This one and this one together, they're different lengths. So it happens with the parallelogram. But will it happen with the rhombus? No, because all the sides are equal. So the adjacent sides are not going to be different. The one after that is the rectangle. It will happen with the rectangle, because again, let's look at those adjacent sides. They're different lengths. And if you go around your shape and have a look at each pair of sides that are next to each other, they are all different lengths. But if you look at the square, all the sides in the square are the same, so they're not going to be next to each other and be different. Okay, the last question I've got on the board here before we go to the next video tells you a description, and you have to decide what quadrilateral we're describing. I am a quadrilateral, so you know it's got 4 sides. Quadrilateral. With opposite sides equal and parallel. So some of you are going to be really good on this stuff. Others are going to have to go through and just go, well, is it a trapezium? No, not both lots of opposite sides are equal and parallel, so we'll rule that out. Is it a kite? Opposite sides equal and parallel? No, that doesn't happen with a kite. Parallelogram? Opposite sides equal, yep, it happens with the parallelogram. It happens with the rhombus. It happens with the rectangle, and it happens with the square. So we're down to 4 shapes here, but they did give you a bit more of a description. My diagonals are equal. All right, the diagonals in a parallelogram are not equal, so it's not going to be that. Here's your parallelogram. Here's the diagonals. We have a long side and a short one. Those diagonals are not equal. So that's not going to be right. The rhombus, let's have a look at the rhombus. Again, even though there's a lot going on for it, it's got a long diagonal and a short diagonal. So those diagonals are not equal. They are equal in the rectangle and they are equal in the square. So we're down to these two now. I have 2 axes of symmetry. All right, the rectangle definitely has 2 axes of symmetry. It goes down that way and across that way. But a square has 4 because it also has the diagonals. So we're down to saying that it's a rectangle. Okay, so I'm going to come back on the next video and we're going to actually do a few geometry questions where we have to give reasons, and with those reasons we're using some of these properties that we're discovering.